Hello students. After refraction and total internal reflection, now we are going to start with spherical lenses today in this video, and after this we will move to optical instruments. So as we all have used these lenses in many ways, like in cameras, projector, microscope, telescope, or simply our spectacles. So all these are lenses that we are going to study now. So we can define lenses as a piece of refracting medium that is bounded by two surfaces. Now those two surfaces, out of those two surfaces, at least one of which should be a curved surface, only then we can call it as a spherical lens. So we can define a spherical lens as a piece of a refracting medium bounded by two surfaces, at least one of which should be curved. So at least one is a curved surface, only then we can call it as a spherical lens. This is how we can define spherical lenses. Now these spherical lenses are divided into two broad categories. One is convex and the other one is concave. So the two categories in which these lenses are divided are convex lenses, or we also know them as converging lenses, and the other one is concave lenses, or we also know them as diverging lenses. These are the two major categories in which all the spherical lenses are divided, and further in these categories there are three subcategories or subtypes of these spherical lenses. Let's see what they are. So for convex lens, the types are double convex or biconvex. Second is plano-convex, and the third one is concavo-convex. Similarly, in case of concave lens, it is double concave or biconcave lens. Second one is the plano concave lens, and the third one is the convexo concave lens. Now first we are defining convex lenses. So convex lenses are those which are thicker at the center in comparison to the edges. Since these are also known as converging lenses because they converge a parallel beam of light and it has a real focus. So to define convex lens, we have to keep in mind 3 points. First, that these are thick in the middle region or at the center. Second, they converge parallel beam of light, and they have a real focus. Their focus is real. Means if there is a lens which is thick at the center in comparison to the edges and converting or converging parallel beam of light and has a real focus, then such type of lens is called convex lens, right? Now this convex lens can be described in a diagram like this. This is a general convex lens. Now there are subtypes also. So when the two surfaces are curved for a convex lens, if the both surfaces are curved, then it is called double convex or biconvex lens. Means ये जो lens मैंने बनाया है, it is a convex lens which comes under the category of biconvex lens, right? There, if there is plano convex lens, then one surface will be curved one side will be curved while the other is plane. Means for plano convex lens it will be like this. One is the curved surface, curved side, and the other one is plane side. Similarly for concavo convex lens, one side is convex while other side is concave, right? So convex side is that which bulges out at the center. Center में जो बाहर निकला हुआ है, this is convex. And again for concave, which has a dip at the center. So this is concave surface, this is convex surface, and the lens is called concavo convex because one side is convex and the other is concave. If both sides are convex, then they are called double convex or biconvex lens. If one is plane and the other is curved convex, then it is called plano convex. While if one is convex and the other is concave, then it is called concavo convex. Similarly, to define concave or diverging lens, we have to keep in mind that these are thin at the center in comparison to the edges, right? They diverge parallel beam of light and they have virtual or imaginary focus. Virtual or imaginary focus. So if there is a lens which is thin at the center in comparison to the edges and diverging parallel beam of light and has a virtual focus, then such lens is called a concave lens, and we can make a concave lens like this. If the lens is like this, then it will be thin at the center and thick at the edges, then it is called a concave lens. And this lens which have both surfaces curved or concave is called double concave lens. This is called double concave lens. But if one of the side is plane, then we call it plano concave lens, right? If one side is plane, then we call it plano concave lens, while if one is convex and the other side is concave, suppose this is concave and this is convex, then we call it as convexo concave lens. Okay, so if one side is concave and other side is convex, then it is called as convexo concave. If one is plane, then plano concave. If both are concave, then it is called double concave or biconcave lens. So this is the division or type of lenses that we have, or with all these kind of lenses we can work. Now there are certain terms which we should know before dealing with these lenses. These are the important definitions or terms that we will use a lot while dealing with these lenses. So we'll start with these definitions first. Let's start. The first term that we have here is center of curvature. So we can define center of curvature as the center of the sphere of which that lens forms a part. Okay, suppose there is a lens like this. If we have a convex lens like this, then this lens will be a part of some sphere. We cut this surface, or to form this lens we cut a sphere like this, and we have cut these spheres to form this lens. Now the center of these spheres, like this sphere जहाँ से हमने इनको कट किया है, the sphere of which these surfaces are a part are called center of curvature. Means the sphere of which this lens or this spherical surface is a part of which sphere, its center is called center of curvature. So there are two center of curvature for a biconcave or a biconvex lens, and we term them as C1 and C2, right? So these are the center of curvature, and we can define center of curvature as the center of sphere, the center of sphere of which lens is a part. जिस स्फेयर का वो लेंस पार्ट है, उसका सरफेस पार्ट है, then the center of that sphere is called center of curvature. Now next thing is radius of curvature. Just as center of curvature, radius of curvature can also be defined in the same manner. It is denoted by capital R. Now the radius of curvature of this spherical surface or this surface of the lens can be defined as the radius of the sphere of which this surface is a part. So this surface is a part of this sphere, then the radius of this sphere is called the radius of curvature. Hence we can define radius of curvature as the radius of the sphere of which lens is a part, or we can say that of which the surface of lens is a part. That will be more better. Then that radius of a sphere is called radius of curvature. Now principal axis, the next term that we have is principal axis. So we can define principal axis as the line that is joining or that is passing the two centers of curvature. Means this line, the line C1 C2 is called principal axis, or we can say that the line passing through two centers of curvature of the lens. जो भी लेंस है हमारे पास उसके दोनों सेंटर ऑफ कर्वेचर से पास होने वाली लाइंस इज कॉल्ड principal axis, and we denote it by C1 and C2. This is the third term that we have. Now moving to the fourth term, this is optical center. Fourth term is optical center, denoted by O, and we can define optical center as, so to define optical center we need the diagram. Suppose this is the optical center of this lens and the points at the surfaces are P1 and P2. Now we can define optical center as a point in between the lens, or as a point which is dividing the thickness of the lens in the ratio of the radii of curvature of its two surfaces. Means this optical lens divide the thickness, this total thickness P1 P2 in the ratio of OP1 upon OP2, which is equal to the ratio of the radii of curvature of the two surfaces of lens. Then the point O is called optical center. Now if R1 and R2 are equal, if we have a lens which has both radii of curvature same, in that case this ratio will be, or we can write it as OP1 upon OP2 is equal to 1. Then in that case OP1 will be equal to OP2, and the point O will lie exactly at the center of this thickness, at the middle of this length P1 P2, and this is the point which is also known as the geometrical center of the lens. Geometric center means according to its geometry it will be the center or exactly middle position. Then in this case, in this situation, the optical center and geometrical center of the lens will coincide. We can remember it like this. So when the two radii of curvature are same, then this thickness will be divided equally by the point O, and at that time it is the optical center as well as the geometrical center, and it lie exactly in between the thickness P1 and P2. This is how we can define optical center. Next term we have is aperture. So aperture is defined as the diameter of the circular boundary of the lens. So we can write it as of the so aperture is defined as the diameter of the circular boundary of the lens. So we can see it in the diagram. Here I am naming it as M1 M2. So here M1 M2 is the aperture of this given lens. It is the diameter of the circular boundary of the lens. This is called aperture. Now the remaining two terms that we have, number 6 and number 7, is the focal length and the principal foci of the lens. Sixth is the principal foci. We are using the word foci here because it is the plural form of the word focus, as each lens has two principal focus. So we call them principal foci. And seventh term is focal length. So these two terms we are going to define simultaneously. Now for this, first I am describing first focus, then I'll move to second focus, second principal focus, and then focal length. So first we are discussing first focus or first principal focus of both convex as well as concave lens. So first for convex lens, this is convex lens. So for convex lens, first principal focus is a point. Here I have denoted it by f dash. It is the point at principal axis. This is the principal axis. So first principal focus is a point at the principal axis such that the light rays starting from this point become parallel to the principal axis after refraction through the lens. After passing through the lens, the rays starting from this point become parallel to the principal axis. Then this point is called first principal focus for this convex lens. Now in case of concave lens, there is a small difference. Since concave lens is a diverging lens, okay, so it can't converge rays at a certain point. That's why the light rays coming to this lens, they all appear to go towards this point. Means all the light rays, these light rays appear to go towards this point after refraction become parallel to the principal axis. In case of convex lens, these rays are coming from that point. In case of concave lens, these rays are coming towards that point or appear to be coming towards that point and become parallel to the principal axis after refraction. This thing is same, that after refraction they will become parallel. So this point here is called first principal focus of concave lens. Since this is the virtual point, this is not, they are not actually meeting here, lines are not actually meeting here, they appear to meet here, that's why it is a virtual point. And concave lens, that's why has virtual focus. So this is the first principal focus for concave and convex lens. Now moving to the second principal focus. Second principal focus. So for second principal focus of convex lens, first the light rays that are coming parallel to the principal axis after converging or after refracting from the lens meet at this point. Actually, these are actually meeting at this point, and this is called second principal focus of this convex lens. So the light rays, those are coming parallel to the principal axis after passing through the lens meet at this point, then this point is called second principal focus of the convex lens. But in case of concave lens, this concave lens is diverging, so it is not possible for this lens to make or converge these light rays meet at a certain point. They will diverge after refraction, so it is not actually meeting, they appear to come from this point, right? This is again an appearance of this situation. So second principal focus for concave lens, we can define that like it is the point on the principal axis such that the light rays, those are incident parallel to the principal axis. These are the light rays, those are incident parallel to the principal axis after refraction through the lens appear to diverge from this point. So these light rays are diverging from the lens, but it is appearing that they are coming from this point, so they appear to diverge from the point F. Then this point is called second principal focus of concave lens. So now I am going to define both first principal focus and second principal focus for both lenses simultaneously. So this is for first principal focus, a fixed point on principal axis such that rays starting from this point or appear to go towards this point after passing through the lens become parallel to principal axis. Principal axis. So the first thing that we say here, the rays starting from this point means that is the case of convex lens, or appear to go towards this point means appear to go towards this point, that is the case for concave lens, means this is for convex and this is for concave. Then after passing through the lens, in both cases they become parallel to the principal axis, then this fixed point is called first principal focus. Now similarly we can define second principal focus. So second principal focus is a fixed point on principal axis such that light rays incident parallel to the principal axis after refraction through lens. Again there will be two terms, two phrases, one for convex, other for concave. So after refraction through lens, either converge to this point, either converge to this point, or appear to diverge from this point, appear to diverge from this point. Now this is for concave, means whether they actually meet or converge to this point in case of convex, or they appear to diverge from this point in case of concave, then this point is called second principal focus. After this there is the term focal length. So focal length can be defined as the distance between optical center and the focus. So if this is the optical center, then the distance between optical center and first principal focus is called first focal length, while optical center and distance between second principal focus is called second focal length. Okay, similarly in case of convex, if this is the optical center, then the distance between optical center and first principal focus is called first focal length, and the distance between optical center and second principal focus is called second focal length. Similarly there are two more terms, first focal plane and second focal plane. So the plane that is passing through the point and perpendicular to the principal axis, means the plane that is passing through the first principal focus and perpendicular to the principal axis, then such plane is called first focal plane, means it should pass from that focus and it should be perpendicular to the principal axis. Similarly the plane that is passing from the second principal focus and perpendicular to the principal axis is called second focal plane. Okay, so, just as focal length, the distance between optical center and first focus is called first focal length, and the distance between optical center and second focus is called second focal length. Now if you observe, sometimes we are measuring the distance towards the right, while other time we are measuring the distance towards left. So there must be some sign convention to represent these directions, whether we are going toward right or toward left. So there is a sign convention that we are going to study further. For sign convention, we have to keep in mind this diagram. Here we have a lens. I have taken convex lens. You can take concave also. It's just for reference. So if this is a lens with optical center O, there is some object and light is coming from left to right. This is the direction from our left to our right. So incident light का direction है left to right. Then in sign convention we have to remember some points that first, all distance that we will measure will be measured from optical center of the lens. Means if you have to find the distance of this object, then you will find it from O. Similarly, if you have to find the distance of this image, we will find it from O. So all the distances are measured from optical centers. This is the first point. All distances to be measured from optical center, or I am writing it as O. Now the distances that we are measuring, if we are measuring them in the same direction as of incident light, that means from left to right or towards the right of this optical center, if light is coming from left to right and the distance that we are measuring is also from left to right, means this distance, this kind of distance we are measuring, then we take it as positive. Otherwise, if we are measuring it in a direction opposite to the incident light, then we take it negative. So second point is direction of incident light is reference, right? So distances measured along it will be positive, and next thing is distances measured opposite to it will be taken as negative. This is the next point. Now next point is for the height. So height is measured either above the principal axis or below the principal axis. If height measured upwards and perpendicular to the principal axis, means this height is measured upward and perpendicular to the principal axis, then it is taken as positive, while if height is measured as downwards and perpendicular to the principal axis, it is taken as negative. So these are the 3 points that we have to keep in mind while measuring the distances. So this is the standard sign convention that we follow while studying ray optics. First, every distance that we have to measure, we will measure it from point O. All these distances, if taken along the direction of incident light, means this, in this case, if it is from left to right, then it will be taken at positive. Otherwise, opposite to the direction of incident light, it will be taken as negative. Next, if the height is taken as upward to the principal axis and perpendicular to it, then it is positive, and if it is downward and perpendicular to principal axis, then it is taken as negative. So these are the points for sign convention that we have to keep in mind. So all this was introduction about the lenses that we should know if we have to study about them. Okay, so further we will study about refraction at convex and concave spherical surfaces. Before that, keep in mind all these points about the lenses. For further videos, stay tuned and keep studying. Thank you.